Stefan, and in this video, we are going to explore how well a buffer can resist an acid attack compared to a simple dilute acid solution of the same pH. For this experiment, we're going to use two solutions. First, we prepared a dilute hydrochloric acid solution with a pH of 5. By now, you should know exactly how to make this because hydrochloric acid is a strong acid which fully ionizes. So by knowing the intended pH of the solution, you should be able to calculate how much hydrogen chloride you need and what kind of volume of water you need to add to get to the right concentration. Then we separately prepared a buffer solution that is also at a pH of approximately 5. This is optional. You may use a universal indicator to determine whether or not your two solutions have the same pH. And if they are indeed at the same pH, the universal indicator should give you the same color for both. And it just so happened that both our solutions have a very pale amber color, which indicates that their pH are similar. Exactly how much those are will be determined with the use of a pH probe that will be connected to an appropriate device. And today I will be using my iPad. Because we're using a pH probe in between measurements, we always have to rinse it with some deionized water, which we're going to collect in a waste container, and we're going to wipe it with Kim wipes. To test the ability of these two solutions to resist an acid attack, we will be using 5 drops of a 1 molar hydrochloric acid solution for each. So here I have a 1 molar hydrochloric acid solution and a pipette with which I will be measuring the same way the 5 drops into both solutions. So first, let's make sure that the pH of both solutions that we have, the dilute hydrochloric acid and the buffer solution, are identical or very similar. I am going to open up the container with my pH probe, rinse it off with deionized water, and I will be using a generous amount. Wipe it off. And then I will carefully insert it into the dilute hydrochloric acid solution. It will take a couple seconds for the pH to record. The pH of my dilute hydrochloric acid solution is 5.08. Now I'm going to rinse it with deionized water and record the pH of my buffer solution. This will also take a couple seconds. And the pH of my buffer solution is 5.05. So the pH of these two solutions is really, really close with 5.08 and 5.05 respectively. Now, I will rinse off my pH probe. Now we place our pH probe back in its container. And we add 5 drops of the 1 molar hydrochloric acid solution into both beakers. 1, 2, 3, 4, 5 drops into the hydrochloric acid solution, and 1, 2, 3, 4, 5 drops into the buffer solution. And with that, we are done with our acid and we set it aside. We swirl our two solutions to make sure that they are homogeneous. And right away, the universal indicator tells us that one of these solutions has substantially changed its pH and the other one stayed relatively the same. So now we're going to test the actual values. Let's remind ourselves that our hydrochloric acid solution had an original pH of 5.08. Now we are going to take our pH probe, rinse it, dry it, and place it back into our hydrochloric acid solution. We give it a few seconds, But we can already tell that the pH changed substantially. It is now at 2.51. And it seems to be settled there. Now let's measure the pH of our buffer solution after we added the 5 drops of hydrochloric acid. The pH of the buffer solution was originally 5.05, and now it is 5.01. So it stayed relatively the same compared to the dilute hydrochloric acid solution, which substantially changed its pH to 2.5.